Hello everyone. Now we are going to start next chapter that is about the prime number properties and their distribution. So there is a architecture that is called the Goldbach architecture. The Goldbach architecture is that even integer can be written as sum of two numbers that are either prime or odd. For example, if I write here a prime number, for example, if I choose 2, then 2 can be written as a sum of two number that is 1 plus k 1. I suppose 3 can be written as a 2 plus k 1 or only 2 plus k 1. That is, I have chosen prime. But wait. 3 cannot be written because we have to choose an even integer. Even 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, like these numbers. Now 4 can be written as a 3 plus k1 or 2 plus k2. So 2 plus k2 are the prime and 3 and 1 are the odd. 6 can be written as a 5 plus k1 or 2 plus k3. Here you can see 2 and 3 are prime, 5 and 1 are odd. 8 and 7. 8 can be written as a 3 plus k5 or 1 plus k7. 1 and 7 are odd, 3 and 5 are prime. 10 can be written as a 9 plus k1 or 7 plus k3 or 5 plus k5, like this. Similarly, we can write any even number as this number. Understood? Now come to the other properties. Now note down this property. Prove that for each prime greater than equal to 5, p square plus k2 is a composite number. Remember one thing, that all these property in the theorem we are going to use in upcoming videos. Just give me a minute. Now how can we prove that for any prime p square greater than 5, p square plus k2 is a composite number? How can we prove that? Proof. Before starting the proof, I want to ensure one thing from you, that do you have information about the prime, that how the prime can be written as I don't know that whether before this video I have already told you or not, but right now I'm going to confirm from you. See, if I write the chain of prime number 2, 3, 5, 7, 11, 13, 17, 19, even any random prime in future, for example, I choose 97 and let's suppose any the prime, if you know, for example, any choose 47, like this. So the primes which are greater than 5 or 5 equal to 5 can be written as a 3k plus 1, 3k plus k2 or 3k minus k1. Now see, 5 can be written as 6 minus k1. 7 can be written as 9 minus k2 or 6 plus k1. 11 can be written as 12 minus k1. 13 can be written as 12 plus k1. 17 can be written as 15 plus k2 or 18 minus k1. 19 can be written as 18 plus k1. 97 can be written as 96 plus k1, and 96 is a multiple of 3k. Here you can see that each of the prime can be written as this information. 6 is a multiple of 3. So it is written as 3k minus k1, 9 minus k2, 6 plus k1, that is 3k plus k1, 3k minus k1, 3k plus k1, 3k plus k2, 3k minus k1. Either 3k plus k2 or 3k minus k1, both are same thing. See here, why? 3k plus k2 can be written as 3 minus k1. Now 3k and 3, among these 3 is common, so I can write it as k plus k1 minus k1. Now k plus k1 is another integer, so I can write it as 3k dash minus k1. Now it can be written as 3m minus k1. The same process, 3k plus k1 or 3m minus k1 or 3k minus k1 can be written as. Similarly, same thing here. For each prime greater than or equal to 5, p square plus k2 is a composite number. Now we will write here, since, now down with me, since p is prime, it must be of the form, it must be of the form either 3k plus k1 or 3k minus k1. Also, one more thing, when p is greater than 5, then note down here, case first, we have to prove that p square plus k2 is a composite number. If p is equal to, let's suppose that if p is equal to 3k plus k1, this is a prime, then p square plus k2, then p square plus k2 will be 3k plus 1 का whole square plus k2 and 3k a plus b का whole square, that is a square, that is 9k square, a square plus k b square plus k 2ab, that is 3 2 is 6, 6k plus k2. It is 9k square plus k 6k plus k3. Among all the 3 terms, I can pick 3 common. It will be 3k square plus k 2k and plus k1. Now p square plus k2 can be written as a product of two number. If some number can be written as a product of two number, that is 3 multiply something, then definitely it is not going to be a prime number. It is a composite number. Understood? Here p square plus k2 is a combination of two numbers. That's why it is a composite number. So here you should write now. Okay, I'm not noting down here. Case 2. If we choose, or maybe possible that p can be 3k minus k1. If p is equal to 3k minus k1, then again same scenario. P square plus k2 will be equal to 3k minus 1 का whole square plus k2 and a minus b का whole square, that is a square plus kb and minus k 3 2 is 6k plus k2. Now 9k square minus k 6k and 2 plus k1 will be equal to 3. Again I can take common 3 from these. That is, if I take 3 common, then it will be 2k square minus k 2k, sorry 3k square minus 2k plus k1. Now again you can see that it is written as a product of two number, first or second. Therefore it is a composite number. Now done. Hence you can write it here as, hence p square plus k2 is a composite number. Please note it down, and if you have noted down, then we can proceed further. Next one. Prove that n to the power 4 plus 4 to the power n is composite for all integer n greater than 1. N to the power 4 plus 4 to the power form. It means something is written like this. If I choose n equal to 3 and 3 to the power 4 and 4 to the power 3, like this, if this is the form 3 to the power 4 plus 4 to the power 3, then this is a composite number. Remember this thing. Actually, the proof of this require the knowledge of mathematical induction. This can be done by you only when you have done induction question in your academic life, like maybe possible in 11th or 12th or 10th, 11th, 12th. So we will prove this with the help of induction. So the concept of the induction is start with by considering the value of n equal to 2. Let, oh no, before starting on the let, I have to write by mathematical induction. By mathematical induction, let us case, that is first wala part. Let n equal to 2. Because we have to consider the value of n to be greater than 1. Then n to the power 4 plus 4 to the power n, that is 2 to the power 4 plus k 4 to the power 2, that is 16 plus k 16, that is 32, and 32 is a composite number. Now next thing, let us suppose let the result holds true for n is equal to k. That is, we are considering that n to the power k plus 4 to the power k is composite number. Third one. Now to prove that the result holds true for n equal to k plus k1. That is, we need to prove that so n to the power k plus 1 to the power 4 and 4 to the power k plus 1 is a composite number. So now we are going to consider, that is k plus 1 to the power 4 plus 4 to the power k plus k1. I am going to discuss the proof here. And if you are not understanding the proof, then you can skip, and maybe possible that if this go difficult, then I will leave it up to you, because I want that you have to do this one. So we are here, k to the power k plus 1 to the power 4 and 4 to the power k plus k1. Now do you know that how to solve the power 4 power? You can use binomial theorem as well as you can use a Pascal triangle. So if I do it by Pascal triangle, then we can write it as 1 1 1 1 2 and 1 3 3 1 1 4 3 and 3 6 3 and 1 4 and 1. It means k plus 1 to the power 4 will be written as a k to the power 4 plus k 4 k cube plus k 6k square plus k 4 of k plus k1. This will be the k plus 1 to the power 4. Plus 4 to the power k plus k1 can be written as 4 to the power k plus 1 4k into 4, like this. Now we have to combine the term which can be combined. K to the power 4 or 4 to the power k, we have to use this because this is a composite number, and to k to the power 4 plus. Can I leave this up to you? Okay, I want to give this question to solve to you. Please solve this. And if you are not able to solve this, then don't worry, because this requires some calculation. Then maybe possible that it is difficult for you if you are have not done induction. Then don't worry, we can do this later. Okay, I'm going to cover next question in next video.